My name is Voldemar Czajnski. I am the contract manager at the construction site for the Non-Invasive Medicine Center developed by Gdańsk Medical University. We started construction in January 2019. The completion is planned for the first quarter of 2021. The scope of the work includes the general contracting for the construction of the Non-Invasive Medical Center, along with technical infrastructure utilities, connections, land arrangement, and delivery of medical equipment. The gross value of the entire project is 191 million zloty. My name is Wojtek Bartoszuk, and I am the construction manager for the Non-Invasive Medicine Center. On our construction site, in addition to the water and sewage system, there is a central heating system, technological heat system, chilled water system, natural gas supply system, a pneumatic dispatch system, and even a helium injection system for our MRI equipment. Increasingly more modern and more extensive sanitary installations play a significant role in all types of the designed and implemented buildings. The most commonly used plastic for pipe systems, among other things, in heating systems is polypropylene. There are three basic types of polypropylene pipes available on the market, and they are homogeneous, stabilized with aluminum foil, and referred to as stabial, and stabilized with glass fiber, known as glass. Here we will demonstrate the assembly of fittings on the can-therm polypropylene pipe stabilized with an aluminum layer. Use a special pipe cutter to shorten the pipes to the desired length. The shape of this tool assures the correct perpendicular angle is obtained while cutting the pipe. Then remove the aluminum layer along with the protective polypropylene layer and the binding layers before welding. On this side of the pipe, insert the stabby pipe into the peeling tool to remove the composite aluminum layer with a twisting motion. You will see debris from the cutting. The length of the section with the removed aluminum foil determines also the welding depth. Always check that the work area is free from residues of aluminum or the binding layer. Cutting blades must not be blunt or chipped. Replace worn blades with new ones. For homogeneous pipes and pipes stabilized with glass fiber, mark welding depth manually with a ruler, stencil, or marker pen. The welding area for individual diameters is given in the corresponding manufacturer's instructions. The surfaces to be welded must be clean, degreased, and dry. Insert the end of the pipe without turning it into the heating sleeve up to the designated welding depth. On the other side, also put the fitting without turning it until it stops over the heating spindle. The heating time will count down only when the pipe and fitting enter into the full depth, that is, into the welding depth. For thin-walled pipes like PN10, first heat the connection only, holding the heating plate from the other side with a heat-intensive tool. After half the heating time has elapsed, start heating the pipe without removing the fitting from the heating pin until heating is complete. Individual welding times are given in the corresponding manufacturer's instructions. After heating time has elapsed, remove the pipe and the fitting from the heating pins at a steady pace and connect them immediately without turning them by inserting the pipe into the fitting until the marked line of the welding depth is covered by the excess material known as the flash. Do not surpass the welding depth, as a narrowing may form in the connection point, and in extreme situations the pipe may even become completely blocked. You can still make slight axial adjustments when you join the elements. It is strictly forbidden to rotate the elements being joined in relation to each other. After the welding time has elapsed, the connection must be secured in place and the cooling time begins, as specified in the relevant instruction supplied with the system. After the cooling time for all connections has elapsed, fill the system with water and subject it to a pressure test. Another system we would like to demonstrate is the can-therm steel system for steel pipes with pressed joints. It is based on pipes and press fittings made from an externally galvanized carbon steel and additionally protected with a passive chromium layer. Cut steel pipes perpendicular to their axes with a rotary pipe cutter. The cut must be complete without breaking off the pipe cut sections. Of course, you can use other tools, provided that the cut is perpendicular and no damage to the cut edges appears in the form of fractures, material loss, or other deformations in the pipe's cross-section. It is unacceptable to use any tools which may generate significant amounts of heat, such as a torch or angle grinder, to cut thin-walled carbon steel pipes. Use a deburrer or a half-round file for steel to chamfer the edges of the cut pipes. Chamfer both the outside and the inside of the ends of the cut pipes. This procedure allows removing any scratches, unevenness, and filings which may damage the O-ring during assembly of the connection from the pipe. Make a visual inspection before starting the operations related to joining the elements together. Verify that the O-ring is in place and the surface is not damaged. When starting the joining process, insert the pipe axially into the connection up to the marked depth. A slight rotation is possible for precise alignment. It is forbidden to use lubricants such as oils, grease, or fats to facilitate the insertion of the pipe. You can use water or a soapy solution. Maintain the appropriate insertion depth of the pipe into the fitting in order to obtain the proper connection strength. After inserting the pipe into the fitting as far as it will go, mark the required insertion length on the spigot end of the pipe or fitting with a permanent marker. After pressing, the marking should still be visible near the edge of the fitting. Special stencils supplied from the system's manufacturer are intended to determine the insertion depth without matching to the fitting. It is recommended to use pressing tools and jaws supplied or approved by the manufacturer of the given system, which should be technically checked before using. Always match the appropriate size of the pressing jaw to the connection diameter. Put the pressing jaw on the connection so that profiling made in it covers exactly the place where the O-ring is seated in the fitting. Convex part of the fitting. Another type of installation we would like to demonstrate are tap water supply systems. Let's start with systems made of galvanized steel with threaded connections. It is the most popular pipe installation system. What a black steel pipe was and still is for heating installations, a galvanized steel pipe was and, to a large extent still, is for drinking water installations. Proven and solid material with high stiffness and resistance to high pressure with solid and proven, typically threaded connections can be processed and assembled with simple, proven tools. Conventionally, the most popular methods of assembling individual sections of galvanized water pipes and fittings are threaded connections. First, place the pipe in a vise to secure it in place before threading. Then, create the threads with a threader. Here, we use an electric threader with a quick change head. During this operation, the thread surfaces should be moistened with coolant. Use a special cooling emulsion for this purpose. The thread surface should be clean from burrs and damaged turns. Incomplete and broken thread turns are allowed up to 10% of the total thread length. Threaded steel pipes are connected with an outer thread on the pipe and with an inner thread in the connections, which are screwed onto the ends of the pipes to be joined. Before applying the sealing material on the surface of the thread, blunt it, for example, with a saw blade or other special device called a pruning knife. This procedure increases the adhesion of the thread surface to the sealing material and thus prevents the sealing material from being pushed out from the connection, while the fitting is screwed onto the thread. The sealant consists of hemp strands with a sealing paste between each layer of the strands and the outer surface of the sealing material. Wind the sealant tightly so that it does not unwind when the fitting is screwed on. In order to save space and time, especially in case of smaller system diameters at residential or commercial buildings, conventional rigid and heavy pipe systems have been replaced with the lightweight and modern systems. Of course, we are talking about plastic and multi-material piping systems, the main advantage of which are lightweight, flexibility, and ease of installation without cumbersome, dirty processing, heavy tools, and as well, space savings. The aesthetics of the performed works and of the finished systems are also important here. A sample assembly of such an installation will be demonstrated on one of the most common systems, which is the TC Flex system, with 3 types of installation pipes and a wide range of versatile fittings made of brass or PPSU material. Measure the appropriate length of the selected installation pipe. Cut the pipe with a sharp cutter dedicated for plastic pipes. The cutter must be sharp so that it can cut at right angles to the pipe axis without leaving burrs or large uneven edges. Slide the clamping ring over the cut pipe with the thinner side always facing towards the connection being made. Then insert into the pipe the expander tool to widen the end of the pipe. An appropriate head match to the diameter of the pipe to be connected allows for easy sliding of the calibrated pipe onto the fitting. Then push the ring towards the fitting as much as possible and then slide the ring with a pressing tool equipped with the appropriate jaw until it is completely pressed against the fitting body. The connection is ready. Another popular type offered by the same manufacturer is the TC Logo system. It is a versatile system consisting of one type of pipe commonly known as PEX and of the set of fittings which can be used both in heating systems as well as in cold and hot water drinking systems. In this system, the use of tools is limited to the absolute minimum, which will be demonstrated by our employees. Of course, all these operations can be successfully performed by one person regardless of the pipe diameter. As with other plastic systems, use a sharp cutter to cut a TC Flex pipe, ensuring that the cut is perpendicular to the pipe axis. Use a rotary pipe cutter for diameters above 33 millimeters. With a rotary motion, process the end of the cut pipe with a system chaser matched to the diameter of the pipe, which removes burrs and gives the right angles to the inner and outer surface of the pipe. After removing the chaser, clean off any material residues and check if the pipe edge is evenly machined or if no burrs are left on it. This step is very important because the pipe edges will come into contact with O-rings in the fitting and may damage them. After inspecting the pipe, remove the protective cap from the selected fitting and push the pipe inside until it appears in the inspection window in the fitting body. The connection is ready. An important feature of the system is that it can be disassembled and reassembled with the same components, for example, after adjusting the pipe length. To this end, use 2 small dedicated keys as demonstrated by our employees. Please note that any system can be used only upon a test and acceptance procedure, and the pipeline has been properly insulated as per the design requirements and in accordance with the relevant standards and regulations. The last system that we will discuss is for sewage systems. The most common connection system for pipes in sewage installations is the socket system. More and more often, PVC material is being displaced, among other things, for acoustic reasons by polypropylene. In polypropylene or PVC sewage systems, the socket joint is one of the quickest and easiest installation systems. Nevertheless, it has also specific procedures and appropriate sequence of operations. An example of a polypropylene socket pipe system is the Magnaplast HT+. Here, cut the pipe to the appropriate length with a saw with fine cutting teeth. The cutting plane must be perpendicular to the pipe axis. Use a guiding trough to facilitate the procedure. Then clean the cut edge of the burrs and process it with a file at angles of about 15 degrees. Before starting the execution of the connection, thoroughly clean the ends of the pipes and fittings to be joined along with the sealing elements of the gaskets in the sockets. Then lubricate the spigot end of the pipe, introduce the socket and the gasket itself with a dedicated lubricant to reduce the friction force during assembly and preserve the socket gasket. At the end, insert the spigot pipe end into the socket until it stops, and then pull it apart by 1 centimeter to create space for natural thermal expansion of the system. Now we will present the tools we use during the demonstration part of the installation. The tools to my left hand are tools for processing polypropylene pipes. The cutter. Of course, we use it to shorten the pipes to the required length. The peeling tool, suitable for the pipe diameter, intended to remove the reinforcing aluminum layer, only for composite pipes with an aluminum layer. Do not use it for solid-walled pipes. And a welding machine, equipped with appropriate tips for heating fittings and pipes. The welding machine heats up to a temperature of 260 degrees, so beware, this device can burn, it is dangerous. The tools on my right are used to make press connections in steel and stainless steel piping systems. This is a roller cutter, which of course can be adjusted to the diameter of the pipe being cut, even up to 50 millimeters. This tool is a deburrer for removing excess material and possible burrs both from the inside of the pipe and from its outer edges. And a press equipped with a jaw, also adjustable to the appropriate pipe diameter. Here, insert a fitting and press it, starting the tool. These components are interchangeable. The tool can be easily adjusted to work with a different pipe diameter. Another group of tools we use during the presentation are the tools for processing the connections of polypropylene pipes and multi-layer pipes. First, the universal cutter. A pipe expander, used to expand the end of the pipe before sliding it over the fitting. Of course, the tool is equipped with the appropriate tips depending on the diameter of the pipes to be connected. And a pressing tool, equipped with replaceable jawstones for pressing the fittings with various diameters. This group of tools is a very basic logo system. The calibrator is used for inner and outer processing of the edge of the pipe inserted into the fitting. It is also equipped with different tips depending on the pipe diameter.